going to prove if y is equal to tan x, then its derivative dy upon dx is equal to sec square x. So let y is equal to tan x. That will be equation number 1. Now let delta x be the increment given to x and delta y be the corresponding increment in y. So the equation number 1 becomes y plus delta y is equal to 10 x plus delta x. Transposing y to right hand side, we have delta y is equal to 10 x plus delta x minus y. Substituting y is equal to 10x from equation number 1, in this equation we have delta y is equal to 10 x plus delta x minus 10x. Now 10x may be written as sine x plus delta x upon cos x plus delta x, and minus 10x may be written as sine x upon cos x. Now taking LCM, cos x plus delta x into cos x. In the numerator we have sine x plus delta x into cos x minus cos x plus delta x into sin x. As we observe, sin x plus delta x cos x minus cos x plus delta x sin x. So here we may apply the formula sin a minus b, because sin a cos b minus cos a sin b is equal to sin a minus b. So using formula we may write it as sin x plus delta x minus x upon cos x plus delta x into cos x. Here in this bracket in the numerator, positive x will cancel negative x and we get only sin delta x in the numerator, and in denominator cos x plus delta x into cos x. Dividing both sides by delta x, we get on the left hand side delta y over delta x is equal to sin delta x upon delta x into 1 upon cos x plus delta x into cos x. Now taking limit on both sides, as limit delta x tends to 0, delta y upon delta x is equal to limit delta x tends to 0 sin delta x upon delta x into 1 upon cos x plus delta x into cos x. By differential calculus, limit delta x tends to 0, del y upon del x is written as dy upon dx. And using the limit theta tends to 0 sin theta upon theta is equal to 1. Here we get 1 sin delta x upon delta x, and here substituting delta x as 0 in this expression we have 1 upon cos x into cos x. So we have 1 upon cos square x, and since 1 upon cos square x is equal to sin square x, because cos is the reciprocal of sec and sec is the reciprocal of cos, so we have sec square x. So ultimately we have dy upon dx is equal to sec square x if y is equal to 10x. So this is the proof of derivative of 10x. As we have proved, the derivative of 10x is sec square x, with the same algorithm we may prove the derivative of cot x is minus cosec x square x. So you better try yourself.